Hi, this is Mrs. Kang. So this homework help is for 6-3 Go Math 1 through 7. Okay, so let's go ahead and talk about number 1. It says drag and drop the correct number of oranges into the boxes to create equivalent rates. Okay, so let's say I have a box. So I'm going to demonstrate just the first one, and then you can do the second one. So here's number 1, and I'm going to create a box, just like the one that I see. And I actually only just needed 2 rows. Here's the apples and oranges. And my original ratio is 9 apples to 10 oranges. The next one says 18 to 20. And then I have 2 blanks. And here I have 27 and 36. Okay, so how do we solve this? When we are writing equivalent rates or equivalent ratios, right here it says equivalent rates, you need to use a multiplicative relationship, meaning you either multiply or divide, but you will not be adding or subtracting. So what I'm saying is this. You can't say, oh, 9 plus 9 is 18, so 10 plus, 9 is, it's not 20. Doesn't work that way. The second thing you need to keep in mind is you always want to start from the original ratio. So when you're using multiplying or dividing to find equivalent rates or ratios, you want to always use the original. So let's take a look. So we know that 9 times 2 is 18 and 10 times 2 is 20. See how that works? What about the next one? 9 times 3 is 27. So to find the equivalent ratio for the number of oranges, I'm going to do the same thing. 10 times 3, and that would make it 30. Next one. I know that 9 times 4 is 36. So then I'm going to do 10 times 4, which would give me 40. And then I'm going to drag 30 here, 40 here. And then I need to do the same thing over here. And then once you drag them right and check, you should be able to get to the right answer. Okay? Well, actually, I'm going to go ahead and do that because I just realized it's a 2-part problem. So let me actually do the next one too. So I have apples and oranges, 3 apples, 5 oranges, and then here I have 6, 9, 12, and 20 is already given. Okay, for this one, 6, 3 times 2 is 6. So I'm going to do 5 times 2, which is 10. Remember, again, I need to use this original ratio. So for the next one, 3 times 3 is 9. So I'm going to do 5 times 3, which is 15. Now the other one is given. 3 times 4 is 12. 5 times 4 is 20. I just know that those are correct. So now I'm going to drag 10 and 15, check. And then that's correct. Now, it says compare the ratios. Is Celeste using the correct ratio of apples to oranges? Drag and drop the answers into the boxes to complete the sentences. Now, here's the thing. If they're using the same ratio, then when you are comparing the 2 ratios with the same denominator, their numerators should be the same. So let's see if we can find that one. Let's see. Oh, I have 2 different ratios from here and here that have the same denominator or same second quantity. There's 10 and there's also the 20. Okay, let's take a look at the one with the 10 as the denominator. The original recipe uses 9 apples for 10 oranges, but Celeste's recipe uses 6 apples for 10 oranges. So obviously, they're not the same ratio. So Celeste is not using the correct ratio because 9/10 is, think about it, greater than 6/10 because 9 out of 10 is more than 6 out of 10. Check. All right, let's go to the next one. Tim is a first grader and reads 24 words per minute. Assuming he maintains the same rate, use the double number line to decide if he can read 130 words in 5 minutes. This is a double number line because it has 1, 2 number lines. That's called a double number line. The first number line represents the number of words he reads. Second number represents the number of minutes. And the question is, so he reads 24 words per minute. This 0, 0 stands for obviously 0 minute, he reads 0 words. Okay, now the question is, can he read 130 words in 5 minutes, but they want you to use the double number line? Okay, you're not gonna be, oh, you are typing? I guess, okay. All right, so then, because you want to find out how many words he reads in 5 minutes and you see this double number line, similar to a table, it just looks different. What I'm going to do is I'm going to do 2 minutes here, 3 minutes here, 4 minutes here, 5 minutes here, and find out, just like with the table, okay? So here's number 2. I'm going to write words, minutes, okay? And here I have the 2 double number lines. Just trying to make it look the same. This is 0 minutes, 0 words. 1 minute, 24 words. This is the unit rate, okay? Now, I'm gonna find out how many words in 2 minutes, 3 minutes, 4 minutes, all the way up to 5 minutes, okay? So I'm going to be using this unit rate. That's my original rate, okay? And I'm going to use multiplicative relationship to find out how many words for 2 minutes, 3 minutes, 4 minutes, and 5 minutes. So 1 times 2 is 2. So 24 times 2, you can use your calculator. 48. Okay. 1, always going back to the original rate or ratio. 1 times 3 is 3. So 24 times 3 is 72. Okay. 1 times 4 is 4. And 24, okay, 24 times 4 is 96. Now, since 1 times 5 is 5, if you do 24 times 5, 120. Now, so first, let me go ahead and type those numbers. 48, 72, 96, 120. Now, but what did they ask? Can he read 130 words in 5 minutes? Take a look at 5 minutes. In 5 minutes, it shows that he's going to read 120 words, not 130. So, no. Tim can read 120 words in 5 minutes. Number 3. Complete the explanation on how to compare 2 ratios. Remember, when you're comparing 2 ratios or rates, remember that video at puzzle that we watched, okay? You find this, well, in the video it says if the denominator is 1, okay, the unit rate, then you can compare the numerators, right? It's a similar idea. So find equivalent ratios that have the same second term, same denominator, then compare the first term, the numerator. Number 4. The Suarez family paid $12.75 for 3 movie tickets. How much would they have paid for 12 tickets? Okay, so this one I'm going to use equivalent rates. So first I'm going to write the rate for 3 tickets. $12.75 for 3 tickets. Now, what I'm going to do is I need to find out how much it'll be for 12 tickets. So I'm going to set it equal to, and I'm going to write 12 tickets. And find out how much that is when I find the equivalent rate. I know that 3 times 4 is 12. So then if I do $12.75 times 4, $12.75 times 4, it is $51. Let's see if that's correct. Okay, number 5. Sue's car used 12 gallons of gas on a 384-mile trip. Jen's car used 5 gallons of gas on a 195-mile trip. Whose car got more miles per gallon? So what I'm going to do here is this is a comparison. And remember, we use unit rate to compare rates. Okay? Now, I have gallons and miles. I'm going to put miles on top for 2 reasons. Number 1, in the notes I said miles usually goes on top. Second reason, if you read here, it says miles per gallon. That means you would put miles on top, gallons on the bottom. Okay, so first, let's start with Sue. This is number 5. Sue's unit rate. So I'm gonna write 384 miles over 12 gallons. And this one, I'm going to find out the unit rate by dividing by 12. I will do that in just a second. Okay. Now, for Jen, it is 195 miles in 5 gallons. And for this one, to find the unit rate, I divide by 5. Okay. So for Sue, 384 miles divided by 12 gallons. I see that it is 32 miles for 1 gallon. And for Jen, 195 miles divided by 5 gallons, and it is 39 miles per gallon. Okay? Okay, so between the two, 32 miles per gallon and 39 miles per gallon, which one got more miles per gallon? Okay, well, if you take a look, 32 and 39, 39 is more, so Jen's car got more miles per gallon. Number 6. Let me go to the next page. Theo drove 240 miles in 4 hours. Lex drove 201 miles in 3 hours. At those rates, could either man drive 180 miles in 2 hours? Complete the explanation. Now, there's multiple ways to solve this problem, but I'm actually going to be looking at a big picture. I'm going to choose a certain way of doing this, okay? Which is going to be using the unit rate. And I'll explain why. Because when I look at my answer choice, I can already tell, okay, I need to select an answer. And then it says Theo's rate is blank miles per hour. and Lex's is blank miles per hour. So in addition to answering, can they drive 180 miles in 2 hours? So I need to find out for 2 hours, but I also need to find out the unit rate. Okay, so I'm gonna find out the unit rate first. Okay, so here's number 6. Theo, 240 miles in 4 hours. And to find the unit rate, I'm going to divide by 4. Okay. Oh. And I'm going to do the same thing for Lex, who drives 201 miles in 3 hours. And I'm going to divide by 3. And that would give me the unit rate for both. First, Theo, 240 divided by 4, that is 60. So 60 miles in 1 hour. And for Lex, 201 miles divided by 3, that is 67 miles for 1 hour. That's not the answer though, okay? These are the unit rates. Now, just as a quick reminder, okay, let's do a quick review. These are rates comparing two quantities in different units. When you divide by the denominator, now this is a unit rate. How many miles per hour? Okay, so over here, I can go ahead and answer this part. Theo's rate is 60 miles per hour and Lex's is 67 miles per hour. But I need to do one more thing in order for me to be able to answer this question, which is, could either man drive 180 miles in 2 hours? So I need to find out how many miles they can drive in 2 hours. Well, that's not difficult at all because I have my unit rate here. All I need to do is find equivalent rate with 2 hours. How do I do that? Well, 1 hour times 2 is 2 hours. So I'm going to multiply my numerator by 2. Same thing right here. 1 hour times 2 makes it 2 hours. So I'm going to do 60 miles times 2 and find out. Well, 60 times 2, it's 120. You don't really need to use a calculator, but I just want to demonstrate. Okay, 67 times 2 is 134 miles. So at this rate, Theo would drive 120 miles in 2 hours. Lex will drive 134 miles in 2 hours, which is, could either man drive 180 miles in 2 hours? They both could. 120 and 134. So both could. And then here are the unit rates. Last one. How can you be sure that all the rates you have written on a double number line, remember double number line, are correct? Complete the explanation. All of the rates should be equivalent to each other. Remember, equivalent rates or ratios. To check, you will, let's see, blank the top term by the bottom term. Hopefully you remember. Divide the top term by the bottom term. Divide the numerator by the denominator. All of the results will be equal if the rates are correct. Okay? When you divide the top by the bottom, if these are equivalent rates or ratios, the answer should always be the same. Okay? So, check. And those are the 7 problems. Okay? Hopefully that helped. Bye.